in calculus, when we differentiate, we're sometimes left with an expression like the one in the following example. And when we have an expression like the one we have right here, we need to simplify it by factoring. So not uncommon to have these two terms. So I like to use a highlighter and highlight each term in an expression. We've got factors. Factors are connected by multiplication. Those create a term. So the yellow highlight is one term and the green highlight is another term. So I first look and see if there's a greatest numerical factor. 3 and 10, they don't have anything in common, so I don't have a greatest numerical factor. So now I'm going to go to the next base. So I have a variable base of x plus 1 in both terms. So I'm definitely going to take out an x plus 1. So I take out an x plus 1 and I look at the exponents. I've got 1/2 and I've got 3/2. The smaller of the two is 1/2. So that is going to be one factor that comes out. The next factor, 2x minus 3, is common to both terms. And I look at its exponents, and the smallest exponent is 3/2. So this right here is my greatest common factor of the original expression. So that comes on the outside of the parentheses, and I'm going to use brackets because I've got parentheses within, so I'm going to use the brackets on the outside. Now I'm going to take each term and I'm going to divide by that greatest common factor. So I'm going to do this rather quickly. And there we go. So I don't have to rewrite it a second time. And now I can say, okay, well, what's left over in the first term is going to go first. And then I'm going to have the plus sign. And then whatever's left over in the second is going to go here in the second term inside the brackets. So we've got x plus 1 to the 1/2 cancels out, so I'm going to be left with 3, and then 5/2 minus 3/2 is 2/2. So I'll have 3 times the quantity, 2x minus 3, and 2/2 is the first power, plus the 10. And then here I have the 2x minus 3 canceling out with the 2x minus 3 in the denominator. However, I've got that x plus 1, and then 3/2 minus 1/2 is 2/2 again, which is the first power. And we can further simplify that. So on the outside, I've got I've got x plus 1 to the 1/2, 2x minus 3 to the 3/2, and then inside the brackets, I'm going to have, because this is a first power, I'm going to have 6x minus 9 plus 10x plus 10, which simplifies to be, and this is just called really great algebra. This is just basic algebra. 6x plus 10x is 16x, negative 9 plus 10 is positive 1, and that is our final answer. I'm going to box it. I'm going to make it a perfect box because that's how I roll. And there's our answer. So let's try another one of these. So here we've got x plus 1 raised to the negative 1/2 power, 2x minus 3 raised to the 5/2 power, plus 10 times x plus 1 to the 1/2 power times 2x minus 3 to the 3/2 power. So again, just to kind of look at this without making my brain do crazy things, I'm just going to separate the two terms using a highlighter, two different colors, and then I'm going to come back and I'm going to say, what do they both have in common? So my greatest common factor, they both have an x plus 1 in common, and between the two x plus 1s, the lower exponent is negative 1/2, so we'll factor that out. And then 2x minus 3 is common to both terms, and the lowest of those two is 3/2. and then we'll be able to see what we have left over. So again, I'm going to divide out that greatest common factor, and I would like to see all of this work when you are working out your practice problems. It's a good habit. My 3 looks like a 5. There we go. It's a good habit to show all your work, especially in some of this complicated algebra that we're working on here. 5 halves minus 3 halves, again, is 2 halves. So I've got 2x minus 3 to the first power plus 10 times, let's see what we've got here, 1/2 minus a negative 1/2. 1/2 minus a negative 1/2. That's 1/2 plus 1/2, which is 1. So I'll have x plus 1 to the first power, and then the 2x minus 3's cancel out. So we'll have 2x plus 10x, that's 12x, and then negative 3 plus 10. So my final answer, x plus 1 to the negative 1/2 power times 2x minus 3 to the 3 halves power, and then inside these brackets I simplify to be 12x. 2x plus 10x is 12x. Negative 3 plus 10 is positive 7. And again, perfect box, because that's how I'm rolling today. Oh, not so perfect. That is not a rectangle. That would be considered just a quadrilateral. There we go. That's a nice, this is a special quadrilateral. It's a rectangle. Now, sometimes this answer is just not going to be good enough. Sometimes they will take this and they will keep the positive exponents positive, and they will make the negative exponents positive by changing their position in the fraction. So this is another way to write it. And it goes even further, because sometimes, let's just change this to a red, sometimes we rewrite that as the square root of x plus 1. So in calculus, there's so many different forms that we can write our answer in. Important for you to be paying attention to everything that you've known from previous courses with your negative exponents, and then changing your rational exponents to radicals. I like the answer I boxed, or I would be even okay with this answer. So this answer would be a good answer as well. Okay, here's one for you to try. The two terms are just on two different lines, but go ahead and try this one, and then I will show you the answer. So press pause, make sure you're giving it a whirl on your own, and then come on back. Okay, if you are just coming back, the answer is 3x minus 1 to the 3 halves power, 13x minus 2, and then I'm going to write it in fraction form, over x plus 2 to the 1/2 power. That's our answer. So hopefully you've got it, you're feeling good, and you're ready to get some practice on those.